technology, both are almost similar. The technology applied from space is called space technology. Remote sensing is also similar. Acquiring information about objects from a far off distance without being in physical contact with the object, and inferring something about qualitatively or quantitatively about the objects or features or the processes is called remote sensing. By the very definition, so many applications come under remote sensing. That means you can do remote sensing from ground or airborne or spaceborne. In fact, human eye is a remote sensor because we are able to see, distinguish, these are boys, these are girls, these are buildings, these are trees, like that, without being in physical contact. So human eye itself is a remote sensor. Like that photographic camera, we are taking so many photographs. That is also a remote sensing instrument. But then why we should go spending lot of amount to space by satellites for remote sensing? That means human eye or photographic camera are limited up to visible region of the electromagnetic spectrum that is radiating from sun. Sun's radiation comes to Earth in the form of electromagnetic waves or radiation, which is comprised of different wavelength regions. If you put in ascending order of wavelengths, it starts from gamma rays, X-rays, ultraviolet, visible, infrared, microwave, radio waves. And again in that subdivisions are there. Infrared is again divided into 4. Out of entire spectrum, human eye is capable of looking at or interpreting, gaining information only in the visible region. If we have power to see in infrared other regions of electromagnetic spectrum also, we can perhaps we need not require microscopes or telescopes. We don't know. So human eye or photographic camera are limited. Whereas if you design sensors which can acquire data and give knowledge or information in other wavelengths of electromagnetic spectrum other than wavelength region, then we can, if we operate them from space, which can revolve around the Earth, we can get lot of information and lot of applications for mapping, monitoring and making the resources, natural resources sustainable to future generations. So that is possible. That's why remote sensing is built not only in visible, in infrared, in microwave, radio waves, anyway we all know, through radio, TV broadcasting is being done by radio waves and position finding systems, global positioning system, GPS, and our own navigation system, IRNSS, they are called location based services. Okay? They are also using microwaves and radio waves. So that entire spectrum is being exploited for the benefit of a common man. That is the specific advantage of satellite remote sensing or space technology. That's why we send satellites. And another advantage is we can study the space environment. We can expand our knowledge in the solar system. We can understand about the interplanetary space. And we can also predict if there is any life in some other planet. If Earth is not enough for us to live in future, Mahatma Gandhi has told there is everything on the planet Earth for human needs, but not for human greed. So what we are doing, wherever is possible, we are trying to live, build houses, we are trying to occupy the forests, hills, valleys, slopes and all. That's why recently that Kerala incident also took place. Kerala landslides occurred. We have all seen so many lives have gone. Lot of casualty and property loss occurred. Why? Our own mistake. Because we have gone into the slopey area and built houses, and there was a heavy downpour all of a sudden. About 190 mm rainfall occurred within few hours, which is supposed to occur in few months. So entire slip landslides have got some triggering factors like slope, loose soil, slope, asphalt, and suddenly sometimes we don't know. All these things will create a havoc, and all these triggering factors joining together make a bigger disaster. So that entire landmass has fallen down. not only that Wayanadu, other 2 villages also got drowned. So many people died. So we should never go against nature. That is the lesson we should learn from Wayanadu landslide disaster. So in case of disasters also, satellite data comes into rescue. So we are supposed to live in plain areas or plateaus. But if we go and live in forests and all, we are making resources, human resources are getting depleted. We are going and occupying the forest, taking that forest resources and making money like that. We are going and spoiling the environment. Any country is protected if it is having at least 30% of the forest area. Then only natural monsoon cycle occurs. We'll get rains in a rainy season. If we occupy that there is no forest means there is no evaporation cannot get condensed and clouds cannot form, they do not get saturation, we don't get rains, there are no rains, no crops, no food, no human life. So we, in case, with all the expanding population, in case if Mother Earth is not sufficient for future generations survival, is there any alternate hope? Are we alone in the solar system or we have any neighbor in the solar system? To check that also, it is one of the objectives of interplanetary missions of ISRO, like Moon, Mars, and very shortly we are going to Venus also, Venus exploration mission, and Mars orbiter mission 2 also, second version is planned, and human space flight anyway is there, Gaganyaan, and we have another mission along with NASA called NISAR, N-I-S-A-R, NASA ISRO Synthetic Aperture Radar. It is the latest technology. A huge amount is being spent to that in order to find out the earthquakes and earthquake identified areas and navigation, disasters and all these natural calamities, and also along with surveillance of our area. So with all these specifications, very soon ISRO is getting collaborated with NASA USA, and a joint program NISAR NISR is going to be launched. So our planetary explorations main objectives are like this, in order to find human lives if any, or in future if humans want alternate home, if Earth is under danger, so if we want to plan to stay in some other planet, whether the conditions are favorable, whether human requirements such as atmosphere, water, these things are available or not, to check that. And additionally, anyway, expanding the knowledge, understanding about solar system always fascinates human mind and it triggers curiosity among the students like you, so that you can take it forward further generations. So these are all objectives of ISRO interplanetary missions. Space technology in our country, those days nobody has imagined. He had the courage of imagination, not only imagination and conception of the space technology and its role in the future generations to come, but also had the courage to convince the government of India and making the dreams realized. All these space technology success stories today we are listening are all because of him only. Next. All these I have already explained. Next. This is, please stop previous. This is the electromagnetic spectrum. All these wavelengths are emanated by sun. So only few wavelength regions are important for remote sensing. Those wavelengths only we create, we manufacture equipment or instrumentation that is called payload. What is a payload in satellite? Payload means instrumentation only, instruments. So they are kept on board a satellite, and satellite has to be taken to orbit by a launch vehicle, which is rocket. Different satellites, different rockets. What makes them different? What is the weight of a satellite you want to take? Up to what orbit height above the surface of the Earth you have to take. Depending upon that, we have to select the concerned rocket. Next. These are all different wavelengths. Microwaves, entire microwave region again is not important for remote sensing. Only few bands. These are the standard bands. And microwave difference is remote sensing is possible only by means of active remote sensing. See, as long as we use sun as the source of energy, that is called passive remote sensing. When we apply our own source of energy to illuminate the ground and collect the data and interpret the information required, it is called active remote sensing. So microwave remote sensing, what all the satellites we are launching are all called active remote sensing. Next. Previous slide. When the sun's energy falls on Earth's surface features, three things happen. Some energy will be reflected back, some energy will be absorbed, some energy will be transmitted. Most of the energy is reflected. Reflected energy is measured by means of sensors on board satellite. That's why because reflected properties are more for different surface features. By means of reflectivity or reflection properties, we can detect and identify different surface features like water, land, trees, crops, vegetation, forest, canals, rivers, hills, valleys. All these things are identified by means of reflected energy. Reflection properties are most important. So most of the remote sensing, especially IRS series of satellites, which are launched into sun synchronous polar orbits, are all called IRS system of satellites, Indian remote sensing. They are exclusively useful for natural resources mapping, monitoring and sustainability of the resources for future generations. And that energy absorbed energy, what happens after some time, they emit certain energy. That is called emission. That energy is measured in far infrared region. That is at 5 micrometer to 8 micrometer. That far infrared region is also called thermal region of the electromagnetic spectrum. Their thermal energy, that means temperature energy. Emission is in terms of temperature. So human beings also we emit some energy. After some time, because of sun's radiation we take, we emit certain energy. Every one of us can be identified distinctly with our emitted energy. That's why during COVID time, you are all aware of COVID? Coronavirus. So during that time, if you want to enter into shopping malls and all, they were using one infrared gun. They used to keep here and measure your body temperature and everything. That is also remote sensing because they don't touch. They keep here. They did not touch. Every human beings also emit certain energy. Like that emission, thermal remote sensing have got specific set of applications. Like coal fire mapping, underground coal seams, if they catches fire, it will extend kilometers together. So coal fire mapping, volcanic eruption, like that certain specific applications wherein emitted energy or thermal energy, mapping of thermal anomalies is important. Even the Earth also behaves like a thermal body. Earth behaves like a magnetic body, gravity body, thermal body. So many parameters are there scientifically. So if you want to measure them, you have to pick up the energy emitted by objects that has specific set of applications. Of course, transmitted energy, it will go inside into the different features. Next slide. Next. And in reflection, there are different types of reflections. Specular reflection, diffuse reflection, like that. If the incident energy angle, reflected energy angle is same, it is called specular. If different directions, if you get multiple reflections, that is diffuse reflector. Like that, these are all properties in order to take out the required information or take out the specific knowledge which we want from the particular satellite mission. Next slide. Next. These are some of the satellite images. See, this is the Hyderabad area. The central one is Hussain Sagar Lake. So, how different the spatial resolutions, the same area appears. If the spatial resolution is more, you can see more clearly the different surface features. So, if the spatial resolution is more, if nearby some different objects are there, like a tree and water body, you can see them as different. If the spatial resolution is low, that means 10 meter spatial resolution is low resolution, 5 meter spatial resolution is high resolution. That means if two different objects are separated by 5 meters, they can be distinguished as different objects. In case of 5 meter spatial resolution data, that is called high resolution data. If it is 10 meter compared to 5, that is low. So you may miss it. If both objects are not separated by at least 10 meters, you may miss them, you may identify it as the same feature. Because the energy gets integrated in remote sensing image, the energy gets in terms of pixels, that means square grids. So in that square grid, entire energy gets integrated and picked up by satellite sensor. So if it is high resolution data, you don't miss features. If it is low, there is a chance of missing features. Next. This is the Rashtrapati Bhavan in New Delhi. If you see in high resolution, how it up, this is a photograph. Next. Next, you can stop this and you can show the number 2 presentation. Presentation 2. Why we should explore the moon? Already we have discussed that. Because the moon is a nearest celestial object to us, and how moon surface looks like. And in fact, actually moon is not different from Earth. Moon and Earth are tidally locked together. What does it mean? They are tidally locked together. That means moon always revolves around the Earth. That's why it is natural satellite to Earth. Earth's one and only natural satellite is moon, and there are about 200 moons in our solar system. Out of 200 moons, our Earth's moon is the 4th largest. And if we understand moon, we can understand the origin and evolution of solar system as well as the Earth features also. How Earth is dynamic, how the evolution of Earth is still going on, internal process. So far we have not clearly understood about Earth also. Earth is a dynamic system. In fact, all the processes in the universe are dynamic. There is no question of static anything. Everything is dynamic. Stars, planets, what is happening will be changing. So all these aspects, if we want to understand about further into the planetary system and expanding our knowledge in the deep space, the first step to be done is we should put a leg on moon. From there we have to go to deep inside the planetary system or solar system, because that is the nearest celestial object. Moreover, it is like a rocky surface like Earth. And according to theories, Earth and moon are formed at the same time. When due to the giant impact, when the Earth is getting created, some mass which is having imbalance, it has been thrown in the space and that has taken afterwards a round shape and is rotating around the sun, according to theories. So what are the minerals and rocks which you have on the surface of the Earth, you may expect the same on moon. That is normal understanding. Now we have to check up. We have to check whether in future moon can act as an alternate home to Earth for human beings, survival or transportation like that. And otherwise, at least can we get the minerals and resources which are getting exhausted in Earth from moon and make the future generation comfortable. So all these things are actually the applications or objectives of moon exploration. In addition to that, theoretically expanding the scientific knowledge, understanding about the planetary system, and transferring the technologies to the future generations to take further and to inspire, not only that, to inspire the student community like you to break the frontiers in the space. All our objectives. Next. Next, Earth and Moon, about 384,000 kilometers from Earth, and it is 1/4 the size of Earth. Next. Yeah, one most important point is from Earth, always we see the same side of Moon. We never see the other side of Moon. Why? Because Moon's rotation around its own axis and revolution around the earth are having the same period of 27 days. That means moon takes 27 days to rotate around itself as well as to rotate around the earth. So all the time from earth we will see only one side of the moon. It is called near side. The other side is called far side. Okay. Next. No atmosphere, no liquid water, but our Chandrayaan-1 launched in the year 2008 has identified water on moon for the first time in the world. But that water is not in liquid form, it is in molecular form. And also as ice, dry ice. So that is our dry ice in the polar regions of the moon. That is exclusively our finding in the world by means of Chandrayaan-1. How we have identified? Next slide. Yeah, moon is having extreme temperatures, scorching heat in the daytime and freezing cold in the night time. So it is very difficult for human survival. Whereas Earth is a pleasant planet, and for streamlining the temperature, balancing the temperature, we have greenhouse gases to warm up the planet Earth, and at the same time because of atmosphere and all, it gets cooled down. So both day and night are equally comfortable for human survival. But in moon, it's not the case. It goes up to minus 180 degrees centigrade in the night. There one lunar day is equivalent to 14 earth days. So continuously for 14 days, moon will be having a daytime of around 150 degrees centigrade temperature, whereas here we cannot sustain even 50 degrees centigrade temperature. In hot summer will burn. So there it is, the daytime 150 degrees centigrade temperature is there. Daytime will continues for 14 earth days. On moon one daytime is 14 days. One night time is 14. Like that. One earth day is equal to 14 moon days. That means 7 days and 7 nights. Okay. So like the extreme temperatures are there on moon. So but what we have identified is, we have identified certain processes, not only water, we have identified some volcanism, geological activity. So therein some volcanic vents also we have identified from moon data. How somebody asked how that moon data comes to Earth? From rover, the data goes to lander. From lander will be having continuous touch with orbiter. Orbiter orbits around the moon at 100 kilometers above the surface of the moon in circular orbits. So the information finally comes to orbiter. From orbiter to ground station, Indian Deep Space Network, that data will be decoded. That data will be decoded, and because instruments are there on board rover and lander also. From the instruments, the data what it sends, we know the instrument what it measures. What is the expected outcome? See, like if you study some subject also, you will have some outcome, some expected results. I should get 100% marks in this studies. So like that, with some aim you will study. So like that, while launching also, for every mission, for every equipment, that means for every sensor, we have certain targets. We know what it measures, what it should measure. That particular region of the electromagnetic spectrum, so that when that information comes, we know from where this information has come, what for it has, the process. We interpret all that processes and we try to identify. Like for example, one thing I will tell. See, we measure certain reflected energy on the moon surface or Mars surface by means of a specified sensors. Okay? And map all of them in a normal graph, x-axis, y-axis. Somewhere you will get peaks, somewhere you will get dips. That dip where it has come, we will try to decode. That dip from this particular wavelength of electromagnetic spectrum. That means at that particular wavelength, if the sun's rays interact with moon surface at this point, this dip has come. That means at that particular area, water absorption band occurred nearly 290 nanometers, something like that, 290, 300. So their absorption means it should have hydroxyl molecule. That only will absorb the sun's energy at that particular wavelength. That's why there is a dip. That all those dip areas have been mapped. At the same time, in the equatorial region of the moon, we got a peak there. That means there is no absorption. That means there is no water. Like this, we decode step by step. We have to identify the knowledge, add that knowledge. From sometimes we may have to refer to the known knowledge, known to unknown. If we are not doing good in some subject, we should know our classmate who is doing good, and we should try to identify what she is doing. Okay, she is studying like this book. This book is standard book. So like that, from known to unknown, we also follow the same sequence for success, and we reach success. Like that, sometimes you have to, when you are especially breaking the unknown frontiers in the solar system, from known knowledge we have to add point by point. From different informations, different sensors, different countries' information also sometimes. So we have to add and all. So finally, India alone, from Chandrayaan-1 mission, water has been identified. But it doesn't mean India alone has done the total thing. Even with NASA, US people, in collaboration with them, even in Chandrayaan-1, out of 11 instruments, 11 payloads, 5 only are from India. All 6 are from different countries like US, European Union, Japan. Equipment is there. So like that, this is the process to identify whether human survival is possible on moon, or to get what are the minerals available there, what are the, because minerals in day-to-day life we require minerals. I have already told you, minerals are everywhere. Even in human body, minerals are there. Of course, different manifestations. Human body, human anatomy, you all would have already taught by your science teachers. So like the calcium, magnesium, all these elements will be there in human. They should be in good proportion, otherwise we are not healthy. So like that, of course, these are in different manifestations. And rocks, minerals and metals are purpose is different. But basically they all belong to elemental level periodic table. Okay? So when we study for Mars also, for this only, of course Mars is having an atmosphere. So there is a chance of human settlement in Mars. Maybe a chance of human settlement because it has got an atmosphere, but not thick atmosphere like Earth. It has got a thin atmosphere, but to some extent it is a terrestrial planet, but there are some other issues have come out from our study. It has got a lot of dust. It's like a dusty planet. So, but terrestrial planet, atmosphere is there, and proportional gravity is there, and a similar, and we are shortly going to Venus exploration also. It is called Chandrayaan-1. So Venus is also having a rocky planet similar to Earth, and Venus density and gravity are also similar to Earth. So we are going for checking the possibility of human survival in future. That is for application. For theoretical interest, knowing the unknown, expanding the knowledge, understanding the solar system, planetary system, these are all research interests which can trigger the curiosity of young minds like you. So that's next. Okay, now you can stop this, and third presentation you can go. This is all moon, how moon looks like. And another major finding on moon's surface is a number of craters. In fact, millions of craters are there on moon surface because of meteoritic bombardment. So these craters from small meters dimensions to kilometers diameter craters are there. So some of the craters are also named on moon and identified position wise with latitudes, longitudes. And the importance of these craters is that they act like windows to understand about the subsurface geological and volcanic activity. So when the geological process, volcanic process is active, that planet is not dead. It is active. As long as the geologically it is dynamic and volcanically active, there is a scope for understanding it further. So with that objective, all these craters have been mapped and being tried. And in addition to that, some volcanic vents also we have observed. Some places that volcanic vents got collapsed. Some other places they formed as a tubes. So that is very, very important for human beings' transportation to moon in the future, because they can take them as shelter. Because otherwise there is no atmosphere. So sun's rays full spectrum falls on moon. That means the harmful ultraviolet radiation also from sun directly hits the moon surface. Because there is no atmosphere, no gravity. That's why atmosphere cannot be retained by gravity. Because 1/6 gravity actually. Moon is having gravity, but 1/6 of Earth's gravity. So that gravity is not enough to hold the atmosphere. When there is no atmosphere, all that harmful ultraviolet radiations are also hitting the moon surface directly. So that is a problem for human being survival. In such a case, what we have identified, detected, mapped precisely, some lava tubes, some are collapsed, some are there. So human beings, if at all they go for scientific experiment, they can hide in them and protecting them from harmful ultraviolet. So like that, all these one by one information we have to add, understand, like value addition, and we should understand slowly one by one, finally to make it a comprehensive study. So this is the, okay, you know, apogee and perigee. So while launching satellites, we launch in elliptical orbits, because you all know India is not a rich country. So what we try to do is, while launching a satellites, we try to put them so many times around the earthbound maneuvers. We call them earthbound. That means we try to fully utilize the Earth's gravitational force while sending a satellite into orbit. So they make many rounds in the elliptical orbits. The nearest point is called perigee, farthest point is called apogee. Why we use is to minimize the cost of launch, to utilize the Earth's gravity maximum. Like you know, in discus throw, the sportsman rounds like this and throw the disc. So like that, we try to utilize the Earth's gravity to send the satellite to a maximum distance. Then only we fire the engines, consuming the fuel. So like that, all our satellites, that's why it has taken, Moon's mission, Sun's mission has taken 6 months. Moon's mission also has taken some few months to reach the destination. So that is another point, cost effective manner. In fact, that is what is attracted by the space community in the world, because India can launch satellites with very minimal cost. You may be remembering Honorable Prime Minister of India, when we have launched Mars Orbiter mission in 2014, he said that per kilometer it costed 7 rupees per kilometer, whereas we cannot travel in an auto rickshaw also with 7 rupees, something like that. So such a minimum cost, we have traveled that much distance. Mars is 225 million kilometers away from Earth. So like that, cost-effective satellite launches or space program has attracted the global space community. That's why all these different countries, they want to send satellites to orbit by means of Indian launch vehicles. That is our success. Next, quickly you go through. Quickly. These are all payloads. This is how it has been launched. Next. This is Vikram lander and its payloads, how it has landed. This is Pragyan rover. It has come down. Next. Now these are the Russian Chandrayaan mission got crashed last year. You know, after our successful launch, within few months, Russians have failed. Because this should be a very foolproof technology. Otherwise, a minor change also, it doesn't mean that Russians are lesser than us. But sometimes a small glitch also can make a big disaster. Chandrayaan landing site. And you know, Chandrayaan landing, Chandrayaan 3 was successfully landed, made a soft landing of the lander on moon surface exactly on 23rd August last year. So that day, Honorable Prime Minister of India has announced that every year, August 23rd should be celebrated as National Space Day to commemorate the success of Chandrayaan 3. Okay, that point here, launching point, he himself has named it as Shiv Shakti point. And previously Chandrayaan 2 also had made, but because of a slight glitch, in the last minute it could not make a soft landing. You would have seen that. It has gone up to 20 meters above the surface of the moon. Just in 20 meters, what happens is that horizontal trajectory should come down to vertical trajectory. It comes like this, then it takes a vertical trajectory, it should land, it should make a soft landing. At that point, from 100 meters it has come down to 20 meters. At 100 meters height only it will come down to vertical this thing. And then they have to operate the descent motors. That means that velocity should be reduced to make a soft landing. At that 20 meters, just 20 meters away, when it has gone 3,84,000 kilometers as per the textbook vision, last 20 meters, it has taken a mild glitch. In descending that, it got a crash instead of soft landing. That's why last year we have. That point was named as Tiranga point. And last year, that successful point has been named as Shiv Shakti point by the Honorable Prime Minister of India. Next, this is actually moon surface. These are all not graphics or anything. Natural photographs which I am showing to you. All these are craters, different dimensions. This is a big crater. That is the landing site. This is the rover. Adjacent to that big crater, that is an autonomous system has been embedded in onboard the lander, so that it can take high resolution photographs. It has got a lunar seismic activity mapping instrument also. What happened in the earlier Apollo missions by US, they have left some seismometers on the moon surface and come back. Seismometers means which can measure the seismicity of the earth. That means earth also behaves like a elastic, rocks also behaves like elastic. If we expand an elastic, it increases its length. Like that, rocks also do have elastic properties. So when that stress-strain relation fails, it triggers. In fact, they are called earthquakes on surface of the earth. Like that, if there are some seismicity that can be recorded by means of seismometers. That data also we have analyzed, and moreover we have already onboard a lander. There is one seismic instrument. On the spot it can take decisions on that. Wherever seismic vibrate, that area it will avoid. And at the same time high resolution camera is there. So much of equipment is with all the help of this equipment. By itself it interprets like a human being. Human thinking power has been embedded in that to take autonomous decision. After the final moment, our control station also will leave it to the lander to take a decision. So it has taken a decision, and finally it has taken a soft landing and flying high the Indian flag in the world. Entire world has celebrated the success. Next. Yeah, next. This is all how the lunar surface looks like. And view captured by Chandrayaan 2 orbiter. You know, Chandrayaan 2 orbiter is still working. So all our missions, actually satellite missions, they worked beyond the designed life of a particular satellite or sensor. Sometimes we ourselves have stopped that activity because we have already reached the targeted outpost. Next. These are all the results. That ILSA, that is what I have told you, the instrument. And these are all different instruments. And how that, these are all the lunar surface. How wavelength versus response in astronomical units. See how that curves, that every dip and every high peak has got a meaning. So everyone will try to identify the precise location, and at the same time will try to identify why the dip has come. So based on that, elemental analysis can be done on moon surface. You know all the natural elements you would have studied in periodic table. Okay, next. Yeah, this is how that this is actually one interesting finding. On the lunar surface, on the Earth's surface, if we go into depth, temperature increases. On lunar surface, for top few centimeters, when we go into depth, temperature is decreasing. Why? All these things are under study now. Next. Next. Okay, moon cakes. This is what lunar seismic activity. ISRO stands for Instrument for Lunar Seismic Activity. That instrument also is kept on board lander, so that they will try to identify the safe zone by means of all these things, and it has landed.